The most expensive mistake in machine learning is trusting accuracy when you shouldn't. You build a model to detect credit card fraud. You test it on 100,000 transactions. It gets 99,000 right, which means 99% accuracy. You love it, you ship it, but let's look closer at the data. In your test data, only 100 transactions were actually fraudulent, which is only 0.1%. Accuracy is a percentage of predictions you got right. Accuracy only works when your classes are balanced, which is roughly 50-50. But the real world isn't balanced. Credit card fraud is probably 0.1% of transactions. Insurance fraud maybe 1 to 2% of claims. So when classes are imbalanced, accuracy becomes a vanity metric. And in that case, you need better metrics, and let's discuss them. The famous confusion matrix. Everything in machine learning metrics comes from this 2x2 grid called a confusion matrix. Let's use our fraud detection example. True positives. Our model says fraud and it is actually fraud. True negatives is model says it is legit, so it's non-fraud, and it is actually a legit transaction. False positives is when model says fraud but the transaction is actually non-fraud. So you declined a real purchase and you get an angry customer. False negative is when model says the transaction is non-fraud but it was actually fraud. In that case, you missed fraud and you lost some money. Every metric we're gonna discuss comes from these 4 boxes. Precision. So of all the times I flagged fraud, how many times was I right? Your model flags 1,000 transactions as fraud. How many are actually fraudulent? 100 are fraud, 900 are non-fraud or legit, 10% precision, which is terrible. If you have 80 fraud and 20 non-fraud, you get 80% precision, which is much better. Precision answers when you block a transaction, is it actually a fraud? Imagine your card getting declined at dinner because your fraud model has bad precision. You are flagging too many legitimate transactions. Use precision when false alarms are expensive. For example, customer satisfaction matters. Manual review is costly and you can't investigate every alert. The next metric is recall. Are you catching all the fraud? For example, caught 50, missed 50, so 50% recall, and you are losing money. If you caught 95 but missed 5, 95% recall, which is much better. Recall answers, are you letting fraud slip through? Low recall equals money lost. Every missed fraud transaction costs you real money. Use recall when missing positives is catastrophic. Financial loss from fraud, security breaches, critical safety systems, and high-value transactions. F1 is the harmonic mean of precision and recall. It only looks good when both are good. If precision is 90% and recall is 90%, in that case, F1 score is also 90. Precision 99, recall 50, F1 is only 66%. F1 punishes models that cheat by maximizing one metric and ignoring the other.